Okay, children, experiment number 1, children, in ninth class. Experiment number 1 in ninth class, children. What are the difference between true solutions, colloidal solutions, suspensions? That's all. Small, very small concept, children. What is difference between true solutions, colloids, suspensions? We studied in detail, children. Anyway, so, again I will say, children, little. They are transparent. They are transparent. They are translucent. Translucent means partially transparent, and they are opaque. This suspensions are opaque. You can't see through them. Okay. Filtration. Children, can we filter this solutions? Children, can we filter the solutions? Children, can we filter the solutions? Anyone in the class? Children, I'll mix
Yes,
this.
sir.
No, I'll mix sugar in the water. Can I separate sugar? Can I separate in filter paper using filter paper?
No, sir, we can't
No,
separate.
sir.
Children, the solute particles cannot be separated. Children, solute can't be separated using filter paper. You have to use some other methods. Using filter paper, I'm asking, you can't separate, children. Using filter paper, you can't separate solutions. And in colloids, children, can we separate, children?
Yes, sir.
The solute children here normally.
No,
Yes.
sir, we can't.
We can, children. I will tell. Suspensions are very, very big, children. Here, we can't at all. We can't at all. At all, we can't separate, children, through filter paper. Here, what happens, children? In colloids, solute particles pass through filter paper, but residue is not left. Okay, children, try to understand. The particles cannot pass through the parchment membrane if you want. Try to understand, children. Here, solute particles can pass. You can't separate them through filter paper. If you want to separate them, you have to take parchment paper. Parchment paper, you will get different type. Okay, and but you will not get residue, children. You will not get residue.
Sir, but we can't separate milk from water, right?
Milk from?
If we add some milk in the water, we can't separate it, right, sir?
I'm talking about milk particles now. Through filter paper, milk particles also will go and through filter paper. I'm telling you. Next stability, children. Children, I will mix the sugar in the water and I will leave it like that. The sugar will come and settle down at the bottom, children? No
No,
residue.
sir.
No, they won't
No,
settle
sir.
down. Means if it is a saturated solution, they won't come, children. No residue is formed, children. You should learn this, children. Okay. Here also, no. But here, yes. Sand in the
Yes,
water is
yes,
the
sir.
best example. Sand in the water is the best example here, children. Sand in the water is very, very good example here, children. Here it will, here, children, here they will settle down. Visibility. Solute particles, children, sugar I dissolve in the water. Can you see through with your naked eye, children? Naked eye?
Yes, sir.
Yes, sir,
Sugar
we can see.
particles, no.
Sugar we can't
Who
see, sir.
said yes? What happened, children? You people, you are forgetting everything. Tomorrow you have exam. How can you see sugar, Nana? Sugar particles. How can you see, Nana? Very, very bad, children. Here we can see sand particles. Yes. Okay. And here also no. Okay, children. And nature, children. This is homogeneous, children. This is homogeneous, children.
Sir, we can see, right, sir?
Here this is heterogeneous. One second, children. Here heterogeneous. Here appears to be homogeneous. They appear to be homogeneous, but they are not really homogeneous, children. It appears to be homogeneous. Appears, but it is really not homogeneous, children. Okay, solute particles are invisible, children. Here we can solute particles are not visible, but in viewed under microscope. If you want, you can view under microscope. Here, solute particles we can see nicely with just with naked eye. You can see, children. Okay, the best examples also we have seen your children. Salt in the water is the best example for solution. Salt water, brine solution. What is the best example for children? What is the best example for colloid, children? Colloid, colloids, milk.
Milk we can. Yes, sir.
Here,
Milk.
what is the best example of solutions? Sand in the water.
Sand in the water.
Chalk in the water. Sand in the water. There is the best example. Children, differences compulsory, very, very important, children. Whether it is for theory and even in the lab manual, it is given. Very, very important, children. This, as it is, they will ask the question, children. As it is, they will ask the question. So you have to remember this, children. So how do you prepare colloidal solutions? How do you prepare simple, children? They will ask. How do you prepare true solution? Just take a water in the test tube, add salt and mix with the glass rod. Simple. Simple, no, children. And how do you prepare this one? They will ask, children. Suspensions. Okay, take a water, mix with chalk powder or something, children, which you get. And how do you prepare colloid? Take water, children, and mix. What will mix, children? Egg albumin, and mix with the water, children. And three of them you pass through filter paper, children. Three of them you pass through filter paper. You will only understand who is passing and who is not passing, children. Everything we can see, children. Okay, take a suspension, colloid, and true solution, and three different. Shake all the test tube and keep them in certain, children. Who will settle down and who will not settle down? Also, you will understand. This will not settle down, children. This will not. This also will not settle, but this will settle down, children, because this is a suspension. This is a suspension. Suspensions will suspend at the bottom. Okay, children. Filtration also. Take to filter papers. This will not filter, children. This will not filter, but this can be filtered nicely with the filter paper, children. Nicely with the filter paper, we can separate them. Transparency. Nicely through salt solution, you can see. You can see nicely anything you can see, children, because they are transparent. And this is completely opaque, children. This is translucent. Translucent means that partially you can see, children. So these, children, you have to remember these differences. For theory also it's important, and experiment number one also is very, very important. Okay, children.